I am Sujay Park from OX Wires Corporation. What I am gonna talk about today is aluminium oxide coated bond wire with adhesion promoter and electrical insulation. This is a one-page summary of what I am going to talk about today. You are seeing challenges for surfaces of bond wires. On your left, challenges before encapsulation. On your right, challenges after encapsulation. Before encapsulation, metal wires do not provide electrical insulation. So, metal wires are not allowed to touch with each other. And metal wires do not provide corrosion passivation. So they do not provide good reliability at harsh environment. After encapsulation of packages, metal wires do not provide strong adhesion to epoxy molding compound. On the other hand, the application of an aluminium oxide coating on conventional bond wires offers several advantages. Firstly, it provides electrical insulation. Secondly, it acts as a strong adhesion promoter. Lastly, it helps in corrosion passivation. I am gonna explain how we ended up with coating aluminium oxide on bond wires. Previous works at the top, 2021 ECTC. We presented aluminium oxide coating on PCBCU pad. This year at the bottom, we are presenting aluminium oxide coating on bond wires. On your left side at the top, you are seeing AO wires bonded to typical AL pad. This AL pad always has a native oxide on its surface. Very thin aluminium oxide. However, it allowed good bondability and reliability, which is described by this reference 2014. We wanted to mimic ALOX for PCBCU pads. On your RHS at the top, we made a deposition of ALOX on the PCB pad, and we presented the Bondability and Reliability 2021 ECTC. Today, I am showing you the deposition of aluminium oxide coating on the surfaces of bond wires. In the past, we have observed good bondability associated with aluminium oxide coatings. Aluminium oxide does not interfere with first bonding and second bonding in the same as aluminium oxide coating on PCBCU pads before. Aluminium oxide was coated on bond wires by making use of ALD atomic layer deposition method. TMA is a precursor and water as a reactant. At the end of the processes, we get to have aluminium oxide coating. ALD is known for excellent conformal coating. On your right side, you are seeing a chamber for ALD coating. This is like a spool for winding long wires. When winding is finished, this whole thing is moved into the chamber for ALD processes. Electrical insulation performances of aluminium oxide coated bond wires. First, simple wire cross. Small weight was applied to the wire cross to make sure that they were in contact. No short. Second, aluminium oxide coated wires were wound around the small round bars. 1 mm and 2 mm diameters of the bars. When the bar was big, we did not observe any cracking on the aluminium oxide coating. However, when the bar was as small as 1 mm, cracking occurred on the aluminium oxide coating on the wires. Crack spacing was about 0.5 The maximum strain of the aluminium oxide was found about 3.5%. However, there was no electrical short even after cracking of aluminium oxide coating, because of strong adhesion of aluminium oxide. Looking at the cracking pattern. Even after the cracking like a mud crack, aluminium oxide did not peel off, so electrical short did not occur between two wires. Number 3. Conductive paste was applied to the aluminium oxide coating. No electrical short. Number 4. Wire bonding made wire cross. Wires were depressed with each other so that wire loop height was reduced. Looking at the case C, you can tell the loop height much smaller. If wire loop deflection is small than 10% of height change, no electrical short. If more than 10%, electrical short occurred. Number 5. Wire touch was applied to DRAM memory packages, and number 6 is cameral module packages. Left-hand side. Wire looping created wire touch in the DRAM packages as shown. Aluminium oxide coating 0% short. Conventional wire no aluminium oxide coating 15% short. Next, wire cross case. Aluminium oxide coating 4% short. Conventional wire 24% short. For the case of camera module package, wire cross was made. 0% short occurred for aluminium oxide coated bond wires. Here, I have to tell you, the guideline was satisfied for wire touch testing. On the other hand, the guideline was not satisfied for wire cross. On the next slide, I am gonna explain about the guideline. So, we came up with guideline for wire bonding of aluminium oxide coated wire. In terms of keep out zone, wire kink should not touch with each other. Second, reverse motion zone of the wire should not touch with each other. Because during reverse motion of the capillary, very serious friction and scratch is applied to the wires. Number 3. Too much curvature of the bending should not touch. Number 4. For the case of wire cross, too much loop deflection should not occur. It should smaller than 10%. Last, we recommend that the capillary should slow down for making wire cross.